Good morning, dear viewers. Speaking to you is Teacher Isaac Byamukama, a physics teacher at Crane High School, Entebbe. This morning, you will allow me to share with you in physics. Physics has got 3 papers, but today I will mainly put emphasis on paper 3, which is a practical paper. And this practical paper has got 3 main topics, that is mechanics, light or optics, and then you have electricity. This morning we shall do one practical number in mechanics, and the aim of the experiment that we are going to do shall be the determination of acceleration due to gravity using a simple pendulum. In theory, we are told that the theoretical value of the acceleration due to gravity stands at 9.8 meters per second squared. But practical is here to prove to us the theory. So we shall use the given apparatus to prove the theory and see if we can arrive at a value that is related to the theoretical value. So what do we need for us to do this simple experiment? We shall need what we call a pendulum bulb. This is an instrument we are going to be using as we swing it to determine the acceleration. 2, we shall need a piece of thread at least 100 centimeters, and then we shall need a retort stand with a clamp that is going to be holding this pendulum bulb as it swings in air. Number 4, we shall need a meter rule, 100 centimeters, and its main purpose is to measure the different length of this thread as per the instructions given by the question. And finally, we shall need what we call a stopwatch. This stopwatch is used to measure and record the time taken for the given number of oscillations. For our case, we shall use 10 complete oscillations. So in that case, we are going to go through this question together. You can look at the setup, and that is exactly what we are required of to be having in real sense. So what shall we do? The first procedure tells us that suspend a pendulum bulb from a retort stand as shown in the figure below. So after suspending the pendulum bulb on a retort stand, they are telling us to adjust the length of this thread to a length 0.9 meters, and that is 90 centimeters on our ruler. So we can see that this is 90 centimeters. So after getting 90 centimeters, the next procedure says displace the bulb through a small angle, theta, and then release the pendulum bulb to oscillate. So we shall displace this pendulum bulb slightly to a very small angle and then release it to oscillate. So as it oscillates, we are required in the next procedure to determine the time t taken for 10 complete oscillations. So we shall look at the motion of this pendulum bulb, and one complete oscillation is equal to when the bulb comes this side and then goes back. That's the complete oscillation. So we shall measure 10 complete oscillations, and we shall have to start the watch. Let's start. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. At exactly 10 complete oscillations, we are required to stop the watch. And then we are supposed to come and read the value on the watch. And as you can observe, it is 17.36. 17.36. These are in seconds. So we shall have that recorded as time small t, which is equal to 17.36 seconds as the time taken for 10 complete oscillations. So in that case, we have finished getting the first value. That is when the length was 90 centimeters. So the question continues and tells that you shall be required to find the period time capital T. This period is the same as when you get the time taken for 10 oscillations and you divide it by 10. You shall be able to get capital T. So we shall need to have a table of results, which shall be in this format. This table, it has column L, it has column small t, capital T, and then T squared. So we shall be able to fill the column T by taking the number of oscillations and the time taken in that case. And after that, we shall fill the next two columns by getting the value of T, or capital T, which is equal to small t divided by 10 oscillations. And we shall be able to get the time in seconds. After that, the procedure or the next procedure tells us to repeat procedures above using different length. So we shall have to come and adjust the length of the thread to 80. It says we adjust it to 70, to 60, to 50, and then to 40. As we take the time taken for 10 oscillations. Then we shall have our complete table of results with the values of small t recorded. So after that, we have questions that are following. Question 1 says, plot a graph of t squared against L